Hello friends, I welcome you in lecture number 39 on double integrals. In this lecture, we will discuss one question on area using double integrals. This question was asked in GTU Summer 2019 exam. If you recall, we have discussed in previous two lectures that how to find out area of the region using double integrals. And we know that area is given by double integral dy dx or dx dy over the region which is given in the question. So using this formula we can calculate area using double integrals. So first we understand what is given. Find the area of the region bounded by the curves y equal to sin x, y equal to cos x, and the lines x equal to 0 and x equal to 4. So to find out area using this formula, first we have to identify the limits of integration, limits of x and y. For that we have to sketch the region of integration, and to sketch the region of integration, first we have to decide what are the intersecting points of given curves. Suppose we want to find out intersecting points of these two curves, then we can put y equal to sin x in this equation. Suppose I put y equal to sin x in this equation, I will obtain sin x equal to cos x, and these two are equal if x equal to pi by 4. And if I take x equal to pi by 4 here, I will obtain y equal to sin pi by 4, that is 1 over root 2. So if I consider x equal to pi by 4 in this equation, we have y equal to sin pi by 4, and sin pi by 4 is 1 divided by root 2. That means these two curves y equal to sin x and y equal to cos x intersects at this point, intersects at point x equal to pi by 4, y equal to 1 divided by square root of 2. Similarly, if we take x equal to 0 in y equal to sin x, we will obtain y equal to 0. That means y equal to sin x intersects x equal to 0 at point 0, 0. If we take x equal to 0 in this equation, we will obtain y equal to cos 0, that is 1. Therefore, y equal to cos x intersects x equal to 0 at point 0, 1. And similarly, if we take x equal to pi by 4 here in y equal to sin x, and we will obtain 1 over root 2 for y. That means y equal to sin x will intersect x equal to pi by 4 at point pi by 4 comma 1 over root 2. And same thing here, y equal to cos pi by 4 is 1 over root 2. Therefore x equal to pi by 4 will intersect y equal to cos x at this point. So once we have intersecting points, it is easy to sketch the region of integration. So suppose we consider this is two-dimensional xy plane. Suppose this is y-axis, this is x-axis. X-axis is given by y equal to 0, y-axis is given by x equal to 0. This point is 0, 0. Suppose this distance is pi by 4, then this is going to be pi by 2. And suppose this much distance is 1 over root 2, and 1 will be somewhere here. Now we have to sketch two lines. One line is x equal to 0, that is y-axis. Another line is x equal to pi by 4. So first we sketch x equal to pi by 4. It is the line parallel to y-axis and passing through this point. So suppose this is the line x equal to pi by 4. Now this line intersects y equal to sin x at this point pi by 4 comma 1 over root 2, and y equal to cos x, and this line also intersect at this point pi by 4 comma 1 over root 2. So that point is here, pi by 4 comma 1 over root 2. So now we know that y equal to sin x, for y equal to sin x, if we take x equal to 0, y is 0, so it will pass through origin. At x equal to pi by 4, value of y is 1 over root 2, so it will pass through this point. At x equal to pi by 2, sin pi by 2 is 1, so it will go in this direction. Graph of y equal to sin x will be going in this direction, but we are interested in the graph of sin x between x equal to 0 and pi by 4 only. But let me sketch up to pi by 2. This is the graph of y equal to sin x. Similarly, graph of y equal to cos x. So when x is 0, cos x is 1. So here it is starting from here for x equal to 0. When x is pi by 4, it will pass through this point, and when x is pi by 2, cos pi by 2 is 0. So graph of cos x will look like this. It is in between 0 and pi by 4, and we can extend up to pi by 2 to understand that how it is going. So this is suppose y equal to cos x. Now we are interested in the area between x equal to 0 and x equal to pi by 4 only, and area between y equal to cos x and sin x between x equal to 0 and x equal to pi by 4. So this is the boundary of y equal to sin x, this is the boundary of y equal to cos x, and we have to consider area between 0 and pi by 4. So this is the region of integration. We are interested in the area of this region, which is bounded by y equal to cos x, y equal to sin x, and the lines x equal to 0 and x equal to pi by 4. So once we obtain the region of integration, we have to decide the limits of integration, and we are using double integrals to calculate areas. So we have to select that which order of integration we want to prefer. If we want to integrate with respect to y first, we have to consider horizontal line passing through the region of integration, and if we want to integrate with respect to x first, we have to consider horizontal line passing through the region of integration. But you can see, if I consider order of integration first with respect to x, then our area is like this. So if I consider horizontal line above this line, then we can see, if I consider horizontal line above this line, which is above this point, then horizontal line will enter at x equal to 0, but it will leave on y equal to cos x. And if I consider horizontal line in this region, then it will leave on y equal to sin x. So if we want to select integration with respect to x first, we have to divide the region of integration into two sub-regions, and then we have to add those two double integrals. But if we select order of integration as first with respect to y, then we will consider horizontal line, and we can see that horizontal line will enter at the point, and that point will always be on y equal to sin x, and the vertical line will leave on the same curve y equal to cos x. If I consider vertical line in any part of this region, then it will enter on the same curve and it will leave on the same curve. So it is advisable to select order of integration as first with respect to y, so that our work will be reduced. So we consider a vertical line passing through the region of integration. Now on vertical line, x becomes constant and y is changing. At this point, line is entering in the region Now this point is on this curve, which is y equal to sin x. So we write that this line enters at y equal to sin x. Line is leaving the region at this point, so we write that line leaves at this point is on the curve y equal to cos x. So we write that leaves at y equal to cos x. Now the leftmost points of this region are on y-axis. So here value of x is 0 and there is only one rightmost point, and which is on the line x equal to pi by 4. So we will consider limits of x as from x equal to 0 to x equal to pi by 4, and limits of y will be from y equal to sin x to y equal to cos x. So now we write all these things, that the region of integration is as shown in figure. The region of integration R is shown in figure, and we consider a vertical line. We consider a vertical line passing through region R, and we find that the limits of integration are limits of y are from y equal to sin x to cos x. Y is from y equal to sin x to y equal to cos x, and x is from x equal to 0 to x equal to pi by 4. Now we write down the formula for double integral. So we know that area using double integral will be equal to double integral over r dy dx. We are considering vertical line, therefore order of integration is first with respect to y and then with respect to x. So first we write down limits of y, which are y equal to sin x to cos x. Limits of x are from x equal to 0 to 4. First integral is with respect to y and then with respect to x, and here we keep in mind that while integrating with respect to y, we will consider x as constant. Now here our function is 1. Integration of 1 with respect to y is y, and limits of y are from y equal to sin x to y equal to cos x. Here upper limit is not 4, it is pi by 4. And then we will integrate with respect to x. Now we put limits of y, which are from sin x to cos x. Integral from 0 to pi by 4. Upper limit for y is cos x minus lower limit for y is sin x. Now this is problem of function of only one variable. Integral of cos x is sin x and integral of sin x is minus cos x. So negative negative positive, we have sin x plus cos x. Limits of x are from 0 to pi by 4. So now we have sin pi by 4 plus cos pi by 4. This is for x equal to pi by 4, which is upper limit. Upper limit minus lower limit. Sin 0, which is 0, and cos 0, which is 1. Sin pi by 4 is 1 over root 2. Cos pi by 4 is also 1 over root 2 and minus 1. So 1 by root 2 plus 1 by root 2, that is 2 divided by root 2 minus 1. And we can write 2 as square of root 2, so that we write our answer in this form. 1 square root of 2 will cancel out, and required area is square root of 2 minus 1. So in this way it is easy to calculate area using double integrals. You just have to take care of limits of integration, and for limits of integration it is always necessary to sketch the region of integration. From the region of integration you will get the idea that which order of integration you have to select, either with respect to y first or with respect to x first, and depending on the type of region of integration you should decide that whether you should consider vertical line or horizontal line. You can do the same problem using horizontal line. In that case you have to divide your region into two sub-regions, and you have to find out value of double integral over this region as well as this region, and then you have to add those two double integrals. But if we consider vertical line, then we don't have to divide the region into two sub-regions and our work will be half. So better choice is advisable. You should select wisely that which order of integration we should consider. So this is all about this session. I hope you like it. Thank you very much.